So my talk is entitled Full Stack RX with Reactive Extensions. So what I'm really going to teach you is a bit about the Reactive Pattern and the Redux Pattern and show you how you can use those patterns inside your C# code. So this is me, my name is Brendan Richards and I'm a Solution Architect at SSW based in Brisbane, and that means I spend most of my time on site building applications for clients, and I occasionally get out of the client work to do some training. I do the Angular Hack Days, I do the .NET Superpowers tours for .NET Core, and I also do the Superpower tour for Angular, so they're great things to go to. And I also get out to do these user groups now and then as well. And in recent times, I've been doing quite a bit of work with the Redux pattern when I'm building single-page applications in JavaScript, and I quite like it. And so I'm looking to find new ways of using that pattern elsewhere. So what I've said here is NGRX and Redux, my new favorite hammer. I'm now looking for more nails. And the reason I'm looking into this is because it's a pattern that's applicable in many other places that might not typically be applied in those places. So I'm going to try and explain what that pattern is and how you can go about using it in other places beyond just the kind of JavaScript single-page apps, which is where it's most commonly used. So what I'm going to talk about, I'm going to start with an introduction to RxJS, Redux, and NGRX. So these are the basic concepts to get across of what reactive programming is and what Redux is. Then I'm going to talk about the C# versions of those libraries. So the introduction, I'm going to show you the JavaScript versions because they're the most common ones. They're what you're most likely to use when you first go about using the Redux pattern. I'm then going to show you the C# libraries that perform a similar operation inside C# code. Then I'm going to show you my demo. So in order to prove what you can do with this thing, I've created a demo. And what this demo does is screen sharing inside an Angular application. Now, I don't want you to go away thinking, right, this Redux stuff is about screen sharing between two applications. But it's an example of what you can achieve when you wire up all these technologies. The next thing I'm going to do is I'm going to talk about Redux my way. This is really taking the libraries I found on the internet and tweaking them and reusing them and making them work in a way I wanted to work with so I could build a more complicated, bigger application. And I'll explain myself as I go there. And finally, wire it together with SignalR is going to explain how to use SignalR to wire up all this technology together to make the final application. So let's start with our introduction to the RxJS, Reactive, and the Redux pattern. So reactive programming is all about this thing here called an observable. And so the observable is a thing that contains a piece of data. So in this example here on this slide, I've got an observable, and it contains a number 1. But what we do with observables is observables contain data that change over time. So we represent that change of data as an array. So we've got an array with one thing. So at one point of time, we had one value called number 1. So what we do with observables is we can observe them. So the idea is you have an observable that emits events and an observer that receives those events when they change. So we've got one observer here watching that observable, and that receives the value 1. If that value changes over time, then the observer receives that value. So this is a kind of push-based notification. The observable is sending out changes to the observer. And so forth. We move forward. So we've got an observable, we've got an observer, and we're pushing values through over time. Well, that's pretty powerful just in its own right, being able to receive changes rather than continually poll and say, have you changed, have you changed, have you changed? But the reactive programming adds a lot more power on top of this. The first thing it does is it gives you the ability to insert operations into this stream. So we've got an observable at the top here, and into that observable stream we've put this map function, map x plus 1. So what that's doing is taking in this observable, this number 1 that's come from the observable, and it's adding 1 to that value, and it's pushing through another arrow. So the thing to remember here is each of these arrows are observables in their own right. I can listen to the original observable, number 1, or I can listen to the second observable after the map, number 2. So I hope you get the idea that you can build up this chain of functions. And of course, you don't have to just have one thing listening to observable. We can have two things listening to observable. In fact, we can subscribe to any of these arrows that you see in this picture. So I can subscribe to the output from map, I can subscribe to the original observable somewhere else, or I can subscribe to the next one. And filter is interesting because this one is stripping out values. So I'm receiving values into this filter function. It's only going to emit values out from this filter function if they're greater than 2. So you can see the first observable was fetching those values 2, 5, 8, and the next observable was fetching the value 4 and 7. So I want you to get the idea of this observable that emits values, an observer that receives the values, and the concept of these functions or streams of values that you can glue to each other via these functions, via these subscriptions, and the ability to transform in the middle of the stream to something else. The next thing I'm going to show you is one more function, and that's reduce. So reduce is slightly more interesting because this one operates not just on the one value coming through, it operates on the last 2 values that came through. So in this case, this particular function has a piece of state involved. It knows what was there, it knows what it's got, and once you've sent 2 values in, then it can process them. And hopefully you see the deliberate mistake here. 4 plus 7 is not 13. So any questions on that so far? So the idea is you've got an observable, emits values, you've got various functions to transform those values or work with those values as they come through. Any one of these dotted line arrows are observables again in their own right that you can subscribe to yourself and glue up and build up these chains of changing numbers. Okay, so where does this become useful? So we're using this a lot in client-side JavaScript code. And in fact, this concept of the observable is baked into Angular right from the beginning. If you're using Angular the new Angular 2 and above, you're using observables everywhere. And the reason they're powerful is because using this, what you're dealing with, your user interface, is all these events firing off. You have events when you click something, you have events when you change a field. So to be able to handle those events in a powerful way, or in a usable way, we use this observable pattern. So here's an example of a piece of functionality that is much easier to write if you're using these observable libraries than if you're doing it before. So what we've got is a search term, and that search term we want to autocomplete. So we want to type into that search term, and once we've typed a few characters in, we want to send a request out to a server to get some auto matches back. So what we can do with the observable pattern is, first thing we do is we grab the observable. In this case, the value changes you see there, that's the function that says, right, a value has changed in this text box. And what we can do is this thing called debounce time. So if you've ever written this before in classic JavaScript, you've got to watch for the search term changing and then start a timer. And if someone types another key before that timer's finished, you've got to abandon that timer and start a new timer. So you've got to write 4 or 5 lines of code. You've got to keep track of that timer. You've got to keep that reference to the timer to clear the last timer. And so you're writing about this much code. Where here we just this one line, debounce time. And what that says is I've got an observable coming into the stream. I'm going to wait 500 milliseconds before I admit. If a new one comes in, I'm going to abandon that one and restart the timer until I get 500 milliseconds where I've not received a value, and it goes straight through. Then I've got distinct until changed. This is going to watch the observables coming in, and it's going to compare the current one with the previous one. So if I type a letter and then delete again within that 500 milliseconds, I'm going to have a new event coming through, but it's going to give me the same value. So it's going to go, right, I'm not going to submit that through. So all this functionality that would have been code and a lot is now just a chain of filters on my event stream. And finally, I've called this line switch map, which will actually go and fire my search to actually fetch my values. So what I want you to come away with here is the idea that some things that used to take a lot of code can be done with much less code and much more readable code using this observable pattern and these observable functions on that stream of events. So any question there on observables, functions, that kind of whole approach? Fantastic. So I think that's the shortest introduction to RxJS. And so the thing with RxJS is there is a fantastic amount of functions to work on this observable stream. But the key thing is you've got this observable, it emits values, you've got observers that subscribe and subscription that passes those through. So that's the introduction to the reactive code pattern. I'm now going to use that pattern and take it even further by adding a pattern called the Redux pattern. And this is a slide we used to present in our Angular course, and it's the Redux pattern is a way to implement a predictable state container. And we used to say JavaScript apps, but I don't think that's right because we can build it in lots of different apps. So why do we do this stuff? Why are we messing around looking to apply these patterns? And this is a slide I bring out quite frequently. And the slide says, in spaghetti code, the relations between the pieces of code are so tangled that it's nearly impossible to add or change something without unpredictably breaking something somewhere else. And that sounds pretty familiar to me. I don't know if you've ever found yourself in that situation. But certainly no one sets out when they build a new project to make spaghetti code. It just organically grows. And the key is dependencies. As soon as you make a piece of code here, dependent on a piece of code over here, and then reverse the dependency as well, you end up locked together and stuck. Well, you take spaghetti code, which is bad enough in the first place, and put it through the blender that it is, all these events firing off from your JavaScript application or whatever system you've got that's processing events, you end up with something called mutable soup. So the idea of mutable soup, if you've got this sea of data that can be changed anywhere at any time, and so anything you do could break something somewhere else because someone else is watching it. So how do you go about avoiding mutable soup? We have to start constraining how you modify your data. You need to push your data through specific pathways so that you only make changes in certain ways, and so you make your system more predictable. So this is my quote. The role of software architecture is to impose artificial constraints in order to promote consistency and predictability. And as far as I can see, the most constraining pattern there is the Redux pattern. So let's talk about this Redux pattern. And what we start with is this thing called the store. So the store is what stores our data that we're going to be working with. Could be a list of customers, could be a shopping cart, whatever it is we're working with, whatever is the piece of data that is our data we're working with, that goes inside the store. And then if you want to read something from the store, and here's an example of a store, this is JavaScript of course, so we've got a store here that's got some state in it, and it's got a list of companies and contacts. So what do we do if we want to use that? We want to display that on our website. Well, we select from that store. And the key thing in this pattern is it's built on top of this reactive Rx pattern. So when we select from the store and push it into our component, our user interface component is going to display this list of customers, we are selecting and creating an observable. So we are now watching that store, and we're watching that store for changes. If the data in that store would change, we would receive that new value. But the key thing of this pattern is we can't just go about changing that store anytime we like. We have to very carefully control how we make changes to that store so that those changes are predictable. We can't select that list of companies into our component and then in the component just go and change it, because then no one else would know that it's changed. So we have to carefully control how we push changes to that store back to the store. And to do that, we raise things called actions. And once again, this arrow is also a stream of observable stuff. And so we raise an action. And each action has two things, as a type and potentially a payload. So we're saying, I want to raise the delete company action, and I'm going to delete the company with the ID 1. So we send that action out, and then that action goes to a special function called a reducer. So the concept of a reducer is it's a pure function, input in, input out, output out, sorry. And what the reducer takes in is the current state of the store. It then also takes in what action was raised. What it outputs is the new state of the store in entirety. So that is the only way these store changes happen. And then, so that then makes the change, pushes that new state through with the companies removed, and it gets updated. So the idea here is all our changes to state happen within a loop. And if you're just looking at this one loop in this one place, it looks like that's a lot of work. Instead of just going and changing and removing something, I've got to, write a selector, I've got to write an action, I've got to write a reducer. But it does mean if other people or other parts of your application are listening to that list of customers, I don't have to do anything apart from raise that action, and the work of pushing that change from the store out to the rest of my application is handled for me. So the idea is you have much more work to set this thing up, much more boilerplate to make your changes. But then as the complexity of the application grows, the things that need to be notified that you've changed something, that's much easier to manage. Those side effects of I've changed something over here, so this thing over here needs to be updated, that gets managed by the framework rather than manually one at a time. Okay, there's one more thing I'm going to show you, and I've got a action coming through here. You remember I talked about reducers, and I said a reducer has to be a pure function, input in, input out. So what do I do if I want to talk to, say, an external database or a logging system? I can't have any side effects baked into my reducer. I can't inject any dependencies or services. So what I can do instead is raise this thing called a side effect. And this is an NGRX concept now, but it's pretty important. So in NGRX, what we can do is raise a side effect. So this is a piece of code that responds to an action, and the side effect can take in services. So now that side effect can do something like talk to our database, which is the most common example, update the database. But then our side effect can't change the state of the store. The only thing the side effect can do is take in this service and work on the service. What the side effect can do is raise another action. So our side effect does our work against our service, such as our database, raises a new action saying this action was successful, and then that action can also take the payload of what we loaded from the database, for example, push through the reducer, and update our state. So this is the loop of how Redux Pattern works, and it's pretty much the same across all the implementations of Redux. So before I move on, any questions around the Redux pattern? I think it's very similar to the MVC pattern, because you've got MVC, you've got this model, which is a bit like the store. View, we've got this component, and the C bit of the controller of the MVC is these actions. So I think there's a direct relationship there between the original MVC pattern and the Redux pattern. It works in a very similar way. But the idea is the only way you change state is in this controlled way through these actions. Okay, so to recap on Rx and Redux and how they kind of work in Angular. Well, firstly, Rx is baked into Angular. It's actually baked into lots of JavaScript libraries now. It's a Reactive Extensions patterns. The Rx side of that story is that observable pattern and the functions that operate on those observables. NGRX builds on top of that to add the Redux pattern. So you can use Rx with observables any way you like without having to do the whole Redux loop. But Redux builds on top of Rx to give you that very constrained, predictable state transformation system. So really the next thing I want to talk about is Rx and Redux are patterns that are available for many languages. So what can I do with those patterns elsewhere? If I take this same pattern and put it on the server side, what can I get away with? Well, let's first start by looking at the libraries we're going to use. So here is a web page from the Reactive X site. And this is really where all the Rx stuff comes from. You can see Rx libraries are available for Java, JavaScript, which you've just seen, and C#, which is rx.net. But you've got also pretty much anything you want to work with, right down to PHP, has the concept of reactive programming inside. It has the ability to make observables and write code that responds to changes to those observables. So this here is the Reactive Extensions library. So this is the C# equivalent of RxJS. Once again, the observable pattern. So when we start looking at RxJS versus Reactive Extensions, you can see there's quite a lot of similarities. They both have the concept of an observable. RxJS has the concept of fat arrow functions. So you have this kind of lambda type thing. C fat arrow, c.name will let you write a function that retrieves the name value out of C. But in C#, we have this thing called Lambda Expressions. And through coincidence, or maybe not, they look almost exactly like fat arrow functions. The difference is fat arrow functions are inline functions in the code that compile to a func, where Lambda expressions are expressions that are primarily processed as an expression, but then they also compile into a func. And the great news is that when you're writing code in both of those sides, it's pretty much the same. With RxJS, when you have an observable, you have all those functions we've seen, like map and filter. So these are functions that operate on the observable object. In reactive extensions for C#, it's slightly different. What you've got is link extensions. So hopefully most of you use link at some point in time. But where link for objects lets you write link commands over collections of objects in memory, and where entity framework and link for entities lets you write link extensions on top of iQueryable. So you write .where and it will compile that into an SQL query and run that in your database. The Reactive Extensions library gives you link operators on the iObservable interface. So you can start using those same things you used to using, like .where or first or default, but now you're doing it on what came from this observable. So that's pretty powerful, pretty cool.
I'm getting a bit confused about timing because if something's happening in real time and it's being observed, I was saying I'm getting a bit confused about timing. If you've got events happening in real time, what's my statement executing on? What data is it executing on?
So that's really, I think it's best to show you the example there, and actually show it in context, because it'll be the data that comes from your store in these situations. We're building Redux stuff, but I'll show you the examples, and then hopefully you'll see where the kind of state comes in and where it comes through. So Redux.net is an implementation of the Redux pattern, this concept of a store, and the actions that can modify the store and reducers. It's that built under .net, so on top of Reactive Extensions. So when you're comparing NGRX and Redux.net, they both have a store. They both raise observables, which you select from your state. They both have the concept of reducer. But where NGRX had the concept of effects, Redux.net doesn't have a specific effects handler, but it does have this thing called middleware. So what I'm going to do is actually show you how I went about adding effects to Redux. So let's go to the demo to actually see what it is I'm trying to build and what you can do. Again, what I'm not going to want you to walk away with thinking is, okay, this technology means I can do screen sharing, but screen sharing is quite a good demo. So let's go ahead and do that. So what I've got here here's my application. So I've got because it's me, it's a Linux machine, and I've got .NET Core installed. And then on top of .NET Core, I've installed a pretty vanilla Angular application. This is using the SPA templates for Angular. This is what you get when you type .NET New Angular. You get this application that is .NET Core plus Angular built in. And what's great with .NET Core 2.1 is the Angular application component of it is 100% compatible with NG and .NET with the Angular CLI commands. So basically you just get a client app folder inside my .NET application that contains my Angular application. So the next thing I did with this application is I installed a database, I installed Postgres, and then I installed Northwind onto that database. Now I've got a great thing to help me do that. A friend of mine, Jason Taylor, he has written this little library, and basically it's Northwind ported to Entity Framework. So he did the whole scaffold from database into Entity Framework and built that up. But then he created a initializer class that inline takes all the data from Northwind and pushes it into the Northwind database as it starts up. So what it means is you can, from anywhere, take a piece of .NET code and go, here you go, start up a Northwind database, and it gives you a working Northwind database, even in Postgres. So that's pretty powerful to just create a demo. So that's where I'm creating my demo from. So with my Northwind database in place, I can go and browse customers. Great, that's Northwind customers. I can click edit, and I can make a change. It's a nice Angular application, so it picks up that I made a change immediately, and now shows I've made a change so I can save changes. Lets me save changes. That's saved. I can go back to my customer list and see that change I made is saved. So that seems to work okay, but that's not much of a demo. That's what this is a pretty standard thing you can do with any line of business application. But let's take a look what happens if I open up a second browser. And I go to HTTPS. /auth. Get myself logged in. Another good thing with .NET Core 2.1 is if you do a .NET new and run it, by default it's got a self-signed certificate to run on HTTPS. It's self-signed, so it's coming up with the not private warning, but it is definitely more secure than just running on HTTP. Let's see, here I am running the application. Let's make sure I can get my customers. Yes, I can. Okay, so if I now open this screen and click edit on that screen and edit on this browser as well, and if I start making changes, let's shrink that a little bit. If I start making changes, you can see the changes I'm making on that form are being published straight across to that other form, and this will work for any number of people that come in and look at this same form as well. So let's change the address to Munich. If I can type, I hit save. Once again, the save propagates straight across. The other side can see that it was saved, so no longer has to save changes. So I think I'm going to show you, if I come back to the list now, I've got a list of customers there. You can see that's the one I'm working on. I can go ahead and change this back to Berlin. But what's not happening here is I'm not publishing the unsaved changes back to the main list. So you can see I'm free to make the changes I want, but if I go ahead and save that, and then hit save, then it updates. So that update came straight through. When I hit saved, it then knew, okay, something's the save process that the then system code is then set up to go, okay, that's saved, and I need to update the list of customers. So that's the kind of thing we're doing, this real-time system. And what's not happening here is there's no polling going on. So if I look at the network, F12. If I watch the network going on, you should see quite a bit of network going on because I'm publishing changes around. All right, it's not going to show me those changes, but yeah, so the idea is it's pushing stuff when I make changes, but this one here, this list, isn't polling until it's told. All these notifications are push-based. When the state changes on the server, that's when it's being pushed through. So let's take a look at the architecture of how we go about building that sort of stuff. Well, first of all the code I'm showing you today has been published to GitHub. And there it is. So you want to take a few seconds and grab that URL. You should be able to get all the code you just saw running on there. It's still pretty early days for this code base, but I've got some of the basics working.
Are the slides up there as well, by the way?
No, the slides aren't up there yet, but I'll put them up.
Thank you.
So this is our architecture. And so what I've got here is actually 2 Redux loops. So obviously I've been using Redux on the client side. So I've got a client-side Redux loop. That doesn't really matter that much. This is just really how I build JavaScript applications these days. But the novel thing is I've also got this Redux loop on the server side. So I've got this store. I've got actions I can raise against that store that can talk to the database. And they're both reducers and effects. I've got SignalR in the middle between the client side and the server side that lets me fire events from the client side to the server side and back again. And I'll show you SignalR in a bit more detail coming up pretty soon. And then also got this concept of selection. So I'm selecting from the store into SignalR. So the complete loop that I've showed you in Redux is happening twice, once on the client side, once on the server side. What I'm really going to show you is the server side and how we set that up. So I'm going to start by showing you this store. How do we keep track of that state we're working with while we're running this application? Well, hopefully you'll see from here that actually that store, that state, is quite simple. I've got two lists. One list is called open customers, and the other list is called the customer list, and they're both of type customer. So I've got these customers, those names, they've seen the fields. I've got the ability to store a list of customers, which is that original list you saw when you first came in. And you've got this list of open customers. And the open customer here is the second half of this screen. Each open customer is the customer record itself, a list of users that are currently watching that user or have that customer open, and an isChange field. And that isChange field is controlling that save button. So if I've made a change to that customer and it's not been saved yet, that isChange field will be true and the save button will appear. If I hit save it or if I undo, then that isChange will be set to false. And that's all the data I need to implement that application. So that is the full state of my store. Okay, so I'm now building on top of that. That is my data. And I'm building this next bit is the store object from Redux that I'm using to store to put that state in. So this type here, store, that comes from Redux. And it's just saying, make me a piece of state, make me a store object that contains this customer state. Pretty much it. So I just take that object I created and I feed it to a store object, which is the Redux concept of a store, and that comes from redux.net. So next thing I'm going to look at is these actions. So what you've seen so far is this thing with the state. Pretty simple state, and it was put inside the store object. The store object itself comes from Redux. But next thing I'm going to talk about is the actions, the things I'm going to raise to make changes to that data in the store. And when I looked at redux.net and looked at the reducers, I found they were quite simple. So this is an example from the web page on redux.net on a simple reducer. It's a reducer that can increment and decrement a single piece of state, which is an integer. But what you can see here is a pattern you quite often see with Redux is that you just have one big function that's your reducer, and then you run through in that function and go, oh, is it this action? I need to perform this I need to add something. Is it the decrement action? I need to decrement, and so on and so forth. And that seems to work, that'll work pretty well. But if I'm building a big, complicated application that's going to build out, I want to be able to break this up into more functions. I want to be able to split this piece of code up into lots of little pieces of reducer that I can then test independently. So those are my actions. So what I'm going to do to make this more enterprisey is I'm going to split this reducer into separate classes, and I'm also going to add the concept of effects. So the idea here with a reducer is you can't inject services into it. So I'm going to add my own side effect system to work more like NGRX. So let's take a look at a single pathway through my application and the actions it will run. So I want to load that list of customers. So I'll raise an action because I start off with an empty store. It's got that structure, but no data inside it. So I'm going to feed it the action, load customer list. And that load customer list is going to call an effect, the load customer list effect, and that's the thing that has the dependency on the database. That will then go and fetch data and bring it back to my application. And it's when the effect is finished, it's going to fire the load customer list complete action. What this does is it's got a payload, and the payload of that action contains the data I've loaded from the database. Then that's going to pass through to the reducer. The reducer can then take that data that's loaded from the database and push it into the store. So let's start with the load customer list action. Well, this particular action has no payload because it's just load the customers. I don't need to know what customer I'm loading, it's just load the customers. So it's as simple as give it a type and make that of type iAction. And that's all I need to do to define an action. It's the minimum, simplest action you can make, just give it a name. So I'm going to fire this named action, pass that into the system, and it'll implement that action. So the next thing we're going to do is a load customer list effect, and this is the thing that talks to our database. So the first thing I'm going to show is this is the bit I've added, the concept of an action effect. So rather than have this whole bunch of reducers and a whole bunch of no effects, I've created this concept of an action effect. This is a type that says, okay, this is an action effect that's going to respond to the load customer list action, and it's going to operate on our customer state object, that thing you saw right at the beginning that had the list of open customers and list of customers coming through. Because this is an effect, we can inject in dependencies. So here we've got, through constructor injection, we're injecting in a DB context. This is how we're going to talk to our database. Then further down the same class, we've now got our effect. Pretty standard code. This is how we go about running a database query, fetching data, and casting it into our in-memory customer object. And the very last thing we do is run that load customer list complete action. So this is the side effect. It receives, this action happens, loads stuff from the database, and then the stuff we loaded from the database, we're going to send to another action. Return new load customer list complete action. So this next action, load customer list complete, slightly more complicated action. Here we've got an action that takes in a payload. But that payload is as simple as a property that we constructor inject. So we've got, again, we're overriding iAction, and we're taking in a list of customers and setting that as a public getPrivateSet customer list. So this is now the shape that we pass through to the next one, load customer list complete. And this is our reducer. So here's our reducer. And once again, we've got this type here called action reducer. So the idea of action reducer is a piece of code that breaks up this big reducer function that was like, oh, you're that action, you're that action, you're that action, and says, right, all I have to do is drop these classes into my solution, and they'll be wired up automatically because I've got this generic type right. So what does the reducer do in this case? Well, it takes in the load customer list complete action. That load customer list complete action has a list of customers. So what this reducer does is take the customers that came from our action and just updates the customer list, returning it into new state. So we've fired an action. That action was load customers. That fired an effect that talked to the database, got our customers in. That passed that list of customers to a new action, which triggered the reducer, which can then update the store. So let me run through that again. Action fires effect, which loads from the database, which raises another action, which goes to the reducer and updates our store. So the next thing I've got here in these slides is actually my implementation of these action reducers that I use to break up the classes, but I don't think they're essential to understand. Do you want me to walk through those before I mean to move on? I think I'll move on. But really what this is the type I've added to let you create these reducers in this reducer per class way. Okay, this piece of code is how I've extended the standard reducer to add support for these action reducers. So what I've got here now is, here's our customer manager, customer store again, that we built based on the Redux pattern. And one thing it takes in is the reducer function to call anytime we want to make a state change. So this function you've got highlighted here, the reducer, is the global reducer for this store. And it runs for every single action we get fed in. But what I do inside this reducer is I take a look at the action and I do an assembly scan to find the reducer type that I made that matches the right shape. I then just manually call that reducer and pass it on. So rather than have this single reducer function, is it a load customer action? Okay, is it this action? I've got instead this assembly scan, so all I have to do is drop in the right reducer functions of the right type into my application, and it will automatically get wired up.
For every call? For every reducer call?
Say that again?
Is it making a reducer for every reducer call? Is it making assembly scan?
Yes, yes. So I think that's something I need to speed up, actually. Yes, good point. Yeah. So at the moment, I am doing assembly scan for every single reducer call. I need to cache that to make it more performant. You're definitely right. So next thing I'll show you, this is the action effect. So I created this concept of an action reducer, which was a piece of code to implement one instance of a reducer. I've done the same for an effect, pretty much a similar pattern. And then finally, we're looking at the store again. This is the piece of code that wires up our store. So we've got our store takes in the state, it takes in the reducer, and it takes in this concept of a middleware. So the middleware is what we're using to implement our effects. Now take a look at the middleware here. And this looks a bit like a piece of middleware from .NET ASP.NET Core. You don't need to look at too much detail, but what happens is what we do here is we always run the original effect. So not the effect, we run the reducer first. So I'm firing an action, and if that action lines up with a reducer that changes the state, we will run that reducer first and finish and change the state. Then, if there are any effects that line up, so these are for side effects, we'll then trigger those effects as well. So I could run an action and have no reducers for that action. It's just fires an effect, like our code list to my list. I could have an action that has no reducers but an effect, like, so the other way around, has no effects but a reducer, like our load customer successful action. Or I could have an action that does both. So I can have an action set up, like, and then it performs an action and saves to the store. But then after that thing is saved to the store, there's some side effect, something on the side that needs to update as well. I can trigger that action on the, as a side effect. So what I've shown you there is this whole chunk here. What we've got is the concept of a store, and a store contains our state. And we've got the concept of actions, and I've shown you how I've broken up those actions to two types. There's effects and reducers, and that's the thing we can work with to make changes to the store. So just that by itself, we've made this self-contained thing where we've got state, and we can update that state in a very, very constrained way. The only way we can change things is by firing these actions. So next thing I'm going to show you is how to wire it together with SignalR. So SignalR is going to be this piece of technology here. And SignalR is vital to this story because it lets us then not only have this Redux loop, but actually lets us send messages in both directions from the client to the server. So let's take a look at how we write SignalR code. And to write SignalR code, you start off with this thing called a hub. So on the server side now, this is, I've opened this up in Visual Studio Code because it's better to zoom in and out. But what we deal with in SignalR is this concept of a hub. And a hub in SignalR pretty much replaces what you'd use a controller for in MVC. So it's the piece of code that runs into the context of your application, and it's the bit that can send messages in and out. So where with an MVC controller, it's receiving HTTP requests in and giving you HTTP responses back. This is similarly, it's working with HTTP, but it's keeping connections open in a hub and then letting you send bidirectional messages, both receive messages from the client and send them to the server. Where our MVC controller only receives requests and sends back responses, this can send and receive messages. So you start off by making a hub, and it's of type hub. Pretty simple. And then in your hub, you just create functions or tasks, such as open customer, or close customer, or update customer. So each of these things is an action that the client can invoke. And as you can see, some of these actions take no properties, and some of these functions can take simple properties. The other thing that the hub can do, and I'll show you an example, is the hub itself can send messages. And I'll jump straight to an example. Here's an example of a hub, and we'll go straight to this line here. The hub can send the messages. And again, the message it sends is given a name. So SignalR has two components. It has the server-side component and then the client-side component. So let's go straight to the client side of the same thing. So if I drill down into my client app, I should see in somewhere here. That's not the right one. Client app, source, app, customers hub. Okay, we've now jumped into client-side TypeScript code. And this takes in hub connection, which is from ASP.NET.SignalR. This is the JavaScript library. ASP.NET/SignalR gives us this concept of hubs inside JavaScript code. And inside our JavaScript code, we're running these little handlers. So this .hubConnection.on push customer receives a changed customer that came through. So let me run through that again and see if we can line them up. So under the server side, we've got this customer hub. And our customer hub send a function called push customer, and that's going to send in our customer details. Our customer hub on the client side receives this .hubConnection on push customer. And again, if this wants to send a message the other direction, we just go this .hubConnection.invoke customer list subscribe. So what I want you to get the idea of now, not look at the code too much, but I can send stuff from the client to the server with a named function. And that named function here lines up with the function name of the server side. You can find the same one. There it is. And I can raise named events on the server side, and they can get caught on the client side, like this. So I've got complete bidirectional communication between SignalR. Any questions on SignalR? It's pretty powerful stuff, and it's now built into ASP.NET 2.1. It used to be available for the classic MVC, but now it's in 2.1 and it's scaling quite well. It's pretty powerful. So one of the points of this talk is to show you that with the SignalR, you've got this bidirectional communication. But what do you do with that communication once you're sending events everywhere? If you don't manage it carefully, you're going to end up with soup. So the real idea of this talk is you've got this bidirectional communication from client to server. Here's how you can put some kind of framework, some control over how those events are received and processed and how you'd make the state changes. So let's actually walk through a bit more of an example now. And we'll walk through the load customer completely now from end to end. So I'm going to start with the customer hub. Actually, let's start here. Let's find the load customer. Okay, so the very first thing you do when you come to your application is you open up that list of customers. You go to that customer screen and you get the list of customers. So what you do, the very first thing you do from the client side is you say, I want to fetch that list of customers. So we have this function here called subscribe customer list. We haven't called it get customers, and that's for a good reason. I've called it subscribe customer list, and I'm going to invoke this function called customer list subscribe. I've also got a handler here called push customer list. So I'm raising this, I'm invoking a function called customer list subscribe. I'm saying from the client to the server, customer list subscribe. And I've also got this listener set up here that's going to receive the command push customer list. So let's take a look at the server side now. Okay, so on customer list subscribe, I've just received that command from the client. And if you read through what I'm doing here, I'm logging a little bit, and then I'm doing this thing, subscribe to store. So store container.customer store, this is the store that I've set up previously, that piece of state that's been set up as a store in the Redux pattern. And from that store, I'm going to select the customer list. So the state is the complete thing, the whole state that had the list of open customers and the list of customers. So I'm going to select from that state customer list. If you look very carefully, if I mouse over that, you should be able to see that the result of this select should somewhere be an observable. Where's the return value here? Okay, so what you get out of this select anyway, from this chain, is an observable comes out of here, iObservable, which we can then call this distinct until changed under. So what we're now setting up is we're firing this customer list subscribe, and what you'd normally do with an MVC application is you'd raise a request and you'd get a response back. You'd say, give me the list of customers, and the response will build that list of customers and give it to you. What we're doing instead here is we're firing off this event. We're saying, set up this subscription. So instead of fetching the customers directly, I'm setting up the state. I'm setting up the description, just saying, okay, I'm going to subscribe to that list, and then I exit. I am not waiting for that customer list to be available. All I'm doing is set up this subscription, .subscribe. So it really ends in this point, .subscribe. And inside the subscribe here is a piece of code that runs much later. Because the code that runs inside this block happens when the store pushes value changes out. So we're no longer fire a request, waiting for it to run, fetch the data, get the data back, send it back down the wire. All we're doing is we're setting up, I'm listening now, okay, and later, when the value changes, we're going to fire this subscription. So what this looks much more like, even though it's C# code, it looks much more like a callback or a promise in JavaScript. So when that customer list gets resolved, or when it changes, we will then call this send async. So what we're doing is we're firing an event, we're saying subscribe to result, and we've got a second process that's going to receive the changes when they occur. So instead of having just one operation to go fetch, request, response, we actually have two. We have a register more interest and receive values when they change. So that sounds like more work, twice as much, because you're sending out a register and then a receive. But what then happens is when that thing changes in the future, I'll receive it again, and I'll receive it again. So from that one setup listen loop, I'm now listening to all changes that happen to that customer list. So do you follow me there? Any questions on that whole layout, whole pattern? Okay, so that's the one for customer list subscribe, and that's how we get the original list of customers into the thing. So let's talk through the customer story now, the actual editing of customers. So the first thing I do to edit a customer is I call the open customer command. So the open customer command, once again, does two things. It sets up a subscription, and then it calls an action. So the first thing it does is it sets up as a subscription, and this one's a little bit more complicated because I'm going to select from the list of open customers where it's the ID I just asked for. So I'm asking for a specific customer ID, and then the subscription I'm setting up says, okay, select from the customer store the open customer object where the customer ID lines up. And that sets up the subscription. And so from that point on, whenever a customer is changed and it comes through here and gets picked up as a customer with a matching ID, it'll go through, run the subscription, and then call this push function. But then what I've got here afterwards is a dispatch. So the dispatch is how I've changed the action. So this dispatch is called open customer. So let's walk through that. Actually, I'll run through this again. So what I'm doing is I get the open customer command coming in. I subscribe to the change. In the future, I raise the event I want to raise, and then I exit. So in the future, when that event I raise is finished doing its stuff, I'll receive the updated value. So let's walk through this open customer command. So we've got this open customer action, and we're passing in two things. The reason we're passing in a user ID is we want to keep track of what are the users that are listening to this user ID. So passing the open customer command, and the very first thing it runs is an effect, because it needs to load that customer from the database, potentially. So that effect runs, and then just goes, finds that particular customer. As you'd expect, it finds that customer matching that ID. Then it returns open customer success. Open customer success is another action. And once again, everything is an I action. that takes in the customer we just loaded, gets fed through a reducer, and that updates our store. So the customer we just loaded goes into the store. As soon as that's happened, back in our hub, where we set up the subscription, this now says, okay, it's getting our new customer through, it's going to run through the subscription, and it's going to raise our push customer command. That's then sending that push customer command down to the client, and the client automatically updates. The final thing I'm going to show you is the save operation, because that has a side effect. If you remember when we did a save, after doing a save, we'd automatically got a new list of customers to our customer list screen. So let me run through that one. If I go back to our hub and I find the customer save operation. So what you find here is you've got a few functions that seem to get very complicated, but then you get a few functions where you're actually doing your more complicated stuff suddenly get very easy, because the piece of work to update that a customer has changed, all I have to do is dispatch an action. I don't have to care about the response because I'm already listening to that response. And again with save customer. So if you have, once you start having programs with more and more change functions, more and more actions you're firing, you find those simplify down because you've got one common way to get the result back once it's finished. So let's take a look at the save customer. We're going to dispatch this action called save customer. Here it is. It's an action, and it takes in a customer and gives us a customer to work with. It's the very first thing it does. Again, it calls an effect. So the save customer effect runs, does the work to actually save to the database. So I won't actually step through this piece by piece, but it's doing the DB context work, save changes, and then reloading the customer. But at the end of it all, it's going to push save customer successful out to our customer. Now, save customer successful, there's a couple of things. Save customer successful has a reducer that updates the save state of our customer back to the store. The most important thing it sets that is changed to false. So if we've saved it, then we've pushed it to the database, we've reloaded from the database. So if there's anything transformation-wise going on in the database, say our database has a kind of database-generated key, then that gets pushed into the state as well. And then we say is changed equals false. So we now know it's no longer in a change state, it's in sync with the database. We can hide that save button. But the second thing we do is this, the save customer reload list effect. So from this one action, we are updating our store and pushing the new customer that's been saved into our database, but also triggering this one more action, and that is our loads customer list action. So we now know, because we've made a change, we're telling the system to trigger that action, and then that action will go and load and update the store again. And basically, we don't have to have that side effect coded in our client side or in our systems. All we need is the listeners in place, the side effect of, oh, I've changed the customer, so the customer list somewhere is out of date. That's handled here in this side effect just by chaining up two events, not by having to have much more code kicking around the edge. So that's what I really want you to walk away with, is the concept that this Redux pattern with these events makes those side effects very easy to manage. They're explicit. If this thing happens, these two things need to update, not having a whole bunch of piece of update stories happening all around the place, because it just happens through this central store and action loop. Question?
Just to understand, is that how you solve when two users at the same time tries to edit the same piece of information?
Yep.
And changes them, one to Munich, the other to Berlin, and then they both submit at almost the same time?
Yep.
When one of them is flagging it is as changing?
Yes, your question is really about concurrency. And I haven't really shown you how to go about concurrency at the moment, because really at the moment what happens is no one's doing anything at the same time. So someone's change would have gone in first. But in fact, what you'll see here is in the demo is if I'm typing and someone else types, it's so quick that if I start typing and someone else starts typing, it happens immediately. There's no kind of saving over each other because you see the change as they're making it. But certainly it would definitely be a consideration how you go about handling concurrency in this type of platform. But yeah, definitely to consider. So I think that covers the kind of conceptual idea. So the thing to walk away with is observables, to have things changing over time. The Redux pattern of how you can constrain changes to your state through this pattern, and then the idea that you can actually make this Redux pattern in as many different servers as you like and rewire them all up through SignalR. And so the concept of working away from the request response cycle, instead having actions and a listening subscription to receive those updates. So let's talk about scalability on this platform. So in some ways it's very scalable, in some ways it isn't. So to start with, the concept of we've made this very fast because all our changes happen in memory first, and we've kind of pushed the saving to the back end. So we're firing less requests to our database because we're keeping all this state in memory. It's almost like a super cache. The only time we're hitting our database really is to do writes and then update based on those writes. And so from a general use perspective, if most people are doing reads, that's going to be faster. The drawback of this is we have all this state in memory on that web server. Now, one of the main points of REST, representational state transfer, and how we build applications these days is we don't put state on the server. We have these, the REST calls have all the state we need, and it's just talking to the database. So it really depends on your application whether that's better or worse, because obviously if you've just got one database in play, you're always going to be constrained by that single database that's handling your state persistence. So you can scale your application out to 50 web servers, but if they're all talking to one database at the back, then that's going to be slow. Of course, you can shard out your reads to have fast reads and slow writes. But certainly when you're talking about web farms, in this kind of model where you've got state on the server, you need to come back to the same server each time to have the same state. But if you're splitting yourself up into microservices and say this, it'd be surprising how much of your state can fit into memory. So provided you design your system well with microservices, you could have a state server that's just for certain parts of your application. And it's totally fine to keep that in memory and sync off. Of course, there's all kinds of things you can do with event sourcing and other things around the way. But with all those other technologies in play, you can still use the observable pattern to actually manage how you're listening to that thing changing in the future. So that's definitely something to consider. So in conclusion, let's have a look at what we looked at. So I talked about RxJS, Redux, and NGRX, quite a conceptual thing to get your head around in the first place. And then we looked at the C# libraries that let us implement that pattern. I showed you a quick demo, and once again, I don't want you to walk away thinking screen sharing is what the Redux pattern is about, but it is about this real-time applications, the idea that you can build your applications with this listen and action effect rather than a request response kind of pattern. Then we looked at some code I wrote on top of the Redux architecture to make Redux bigger and better for sort of an enterprise sort of application that had to handle lots of events. Then we looked at how we could use SignalR to wire all those pieces together, to hit the client side to talk to the server side, and to actually basically we can build applications out of multiple Redux loops. Each individual piece of our application is its own Redux loop in its own right, and it communicates out through SignalR to update other bits of the application. And it's basically multiple loops talking to each other. So there's a lot of reasons I wanted to look at Redux on the server side, this whole idea of this pattern. There is a library out there for the kind of JavaScript world, something called Firebase on the Angular side, that pretty much does some of this stuff. It's a real-time database. You can query and it will send you observables back. And I was thinking there's no reason why we can't have that in .NET. So this gives us a real-time database to query. It's built our own Angular Firebase in .NET using SignalR. One of the other reasons I was really interested in looking at the Redux.NET is, of course, Blazor's coming. And why I'm interested in Blazor? Well, Blazor has a potential to replace all the JavaScript that's going on in our modern applications. But if I want to move to Blazor, I don't want to lose some of the new favourite bits I've just got in JavaScript, which is this Redux pattern. So if we do move to Blazor, I'll be looking to use Blazor with Reactive Extensions and with Redux, so it's a good thing to know. But I actually do believe that there are some workloads that this would definitely work for, whether it's backed by a database or backed by a more robust event sourcing model and service bus stuff. This whole idea of building your applications out of observables rather than just requests and responses is a good one and should be considered. And so thank you for listening.